Hey everyone, welcome back. All right, we are continuing on with functions today. So two things we're going to look at. We're going to switch into the function equations and look at those a little bit more. Those are probably going to be the most common thing we're going to deal with in algebra. So we want to get into that and remember that there are graphs, there are mapping diagrams, there are pairs of coordinates and tables, but of course like the equation side is what we're really going to be working with the most in Algebra 1. So let's really get into that. And we're going to look at this thing called evaluating functions. And you may already know how to do this because we did evaluate equations in Unit 1 very briefly. But let's just make sure we know how to evaluate a function. And that's our question for today. How and what does it mean to evaluate a function? All right, so function notation. What we're going to see at the beginning of a function is this thing where you have a letter and then an x or some other variable in parentheses. So this is not multiplication. So this is not f times x or g times x or k times x or d times t. This is function notation, and this means f of x, g of x, k of x, d of t. So it's a function of x. So x is the input. So the one inside the parentheses is going to be our domain. So this is what's going to be going into the function. And then the output, so what this whole thing is, so this is our y value essentially. So like if we were writing this as an equation, it would be y equals, but in function notation, it's a function of the domain. They basically are the same thing, but they're going to be written differently, so we need to know both. So f of x means a function of x, so the output of that function is going to be our y coordinate. So f of x, this whole thing is one term, so you're not able to separate those. So that's a key thing. Like you can't separate those. You can't divide by g or divide by f or divide by d or x for that matter. You have to keep them together. In a lot of cases, if we have to manipulate the equation anyway, we will replace it with a y and then sub back in f of x at the end, just to make things a little bit easier for ourselves. You're not trying to transfer two different variables around the place. So the dependent variable is the output, so that's the f of x, g of x, whatever it is the y value, and it's a function of the independent. So how the independent one changes will dictate the dependent variable. So if we have this one, f of x equals 3x plus 2, we would say, okay, the output of this function, so this is a function on x, the output is going to be whatever x is, multiply it by 3, and then add 2, and that will give us our output. So y is 3 times the input plus 2. All right, evaluating functions, very straightforward once we're in here, but it just means that we're going to be trying to figure out what is the output of the function at a given input. So if we sub in something for x, what is the y value that would come out? So if we have f of x equals 3x plus 4, and we're asked evaluate f of 5. So that means in the place of x is a 5, so we're going to substitute in 5 for x in this function. So f of 5 is equal to 3 times 5 plus 4. So anywhere there was an x, we subbed in a 5. And then you'd have 3 times 5 is 15 plus 4, and 15 plus 4 is 19. So we would say f of 5 is 19. And if this was a graph, we would say there's going to be a coordinate at 5, 19. So when x is 5, y is 19. That would be on our graph. So just a couple of things to kind of keep an eye out for there. So evaluate means you're going to sub in a given x value. Sometimes, like as we get a little bit harder, it's going to start with numbers. As we get a little bit harder, it might be other like variables. Like it might be something like sub in x plus 5. It's more of an Algebra 2 skill, but we might see it pop up in Algebra 1. Okay, so for which function, different way of asking this kind of question, for which one is f of 3 equal to 7? So we've got 4 options. If x is 3, is y 7? Question mark. So like that's what we're asking here. If I put in 3 for x, do I get 7 as the output? So like for A, f of 3 is 3 times 3 plus 4. 3 times 3 is 9, plus 4 is 13. So that is not true. The output was 13, not 7, so it's not A. Pause the video, do the rest of them, and see which ones out of B, C, and D do fit that description where the output is 7 when the x value is 3. Okay, so second one, f of 3, 4 times 3 minus 5. 4 times 3 is 12, minus 5 is 7, so yes, that one works. For C, this is a select all that apply, by the way, that's why I'm going to keep going. F of 3 for this one is 3 squared minus 2. 3 squared is 9, minus 2 is 7. And then the last one, f of 3, we've got minus 2 times 3 plus 11. Minus 2 times 3 is minus 6. And minus 6 plus 11 is positive 5, which is not equal to 7. So B and C were our answers. Oh, there's an E as well. Let's check E. So f of 3, we've got 3 times 3 plus 5 all over 2. So we got to do the top part first and then divide by 2. 3 times 3 is 9, plus 5 is 14. 14 divided by 2 is 7. So B, C, and E were our solutions. All right, we got 3 practice problems here. I want you to do each of those, pause the video, come back, and see how you did. All right, so for the first one, we got f of 3 again. So 2 times 3 minus 17. 2 times 3 is 6, minus 17 is negative 11. So we would have a coordinate at 3, negative 11. So when x is 3, y is negative 11. G of negative 9. So remember, the letter at the beginning does not matter. It's just this is telling us this is a function. It may be f, it may be g, it may be h. It can be any letter in the alphabet, basically. You probably won't see like x of x, like that's probably the one, or y of x. Like you will probably avoid like the x's and y's because they have meaning in other places. But g of minus 9, we've got negative 1/3 minus 9 plus 11. All right, so negative 1/3 times minus 9, the negative times the negative is going to be a positive number, so it's worth noting. And then 1/3 of 9, or 9 divided by 3, is 3. And 3 plus 11 is 14. So we'll be at minus 9, positive 14 is our solution there. And the last one, h of x, we're doing h of 5. So h of 5 is equal to 4 times 5 squared. Order of operations, exponents comes before multiplication in PEMDAS. So we're going to square this first. 5 times 5 is 25, times 4 is 100. So our coordinate is at 5, 100. All right, that's evaluating functions for the most part. We might see it on graphs. So we'll get given a graph and it'll be like, hey, what is the value of the function at each of these points? So again, remember, this is x values. So f of 0, when x is 0, go down to the graph and be like, okay, it's at minus 2. F of 3, so x value of 3, it's on the y-axis. That means the y value is 0. F of 9, go all the way up. It's at 4. And f of minus 3, come all the way down. It's at minus 4. So graphs, very simple. We'll just go to the x value, see what is the y value at that point. Last thing you might be asked is the point on the graph, or is it a solution for the function? So 3, negative 2, remember, first letter is x, second letter is y, or the output of the function. So if I put 3 in here for x, and I put minus 2 in for the output, so I'm not subbing in for x and making it the output, so minus 2 equals 4 times 3 minus 10. 4 times 3 is 12, minus 10 is positive 2, so minus 2 is not equal to positive 2, so we would say no, not a solution. Okay, so name an additional point that's on the graph. All you'd have to do is pick any x value and sub it in. So say like f of 3, we would do 4 times 3 minus 10. So 4 times 3 is positive 12, minus 10 is positive 2. So we would say 3 positive 2 is on the graph. and that will be a solution. So when x is 3, y is 2. All right, take a look at each of the following questions. Pause the video, come back and see how you did. All right, so for the first one, we have, is 3, negative 2 a solution for f of x equals minus 3x plus 7? We sub in minus 2 for the solution, and minus 3 times 3 plus 7, so we're subbing in 3 for x. Minus 3 times 3 is negative 9, plus 7 is negative 2. So we have minus 2 equals negative 2. They match. This is a solution. It is on the graph. So this would be a point on the graph if we were to draw it out. Second one, 632. Is that a part of g of x equals 5 over 2x plus 12? Let's sub it in. So we got 32 equals 5 over 2 times 6 plus 12. So 5 over 2 times 6, 6 times 5 is 30, divided by 2 is 15, and 15 plus 12 is 27. So 27 not part of the solution. So not equal, so this is not on the solution set. And then for number 3, we've got h of x, and we want to know if the output is negative 14 and the input is 12, does that work? So minus 2 over 3 times 12 and minus 6. So 12 times 2 is 24, divided by 3 is 8, and it's negative 8. Negative 8 minus 16 is negative 14. So this one is part of the solution set. So we had yes, no, yes as our answers. All right, that gets us to the end of today. What does it mean to evaluate a function? It means to sub in a given x value and determine what the y value would be for that graph, what the output would be. And sometimes you may be asked to confirm whether a point is on a graph or not by subbing in for x and subbing in for y. For tonight, take a look at the worksheet in class, and then you also have Khan Academies to do as well. I'll see you next time.